Welcome back to IM1, everybody. Today's topic is 2.1.2. How can I measure steepness? And today we're comparing delta y and delta x. And I'll explain precisely what that means right now. So make sure you guys get today's distance learning target. By the end of this lesson, I will gain an understanding of slope by identifying the changes in y divided by the change in x. And I will continue using the growth and starting values of linear functions. So in the previous lesson, you determined the growth and starting value of a geometric tile patterns and made connections between the pattern, table, and equation, right? So that was pretty much 2.11. So in this lesson, you will use your knowledge to determine an accurate value of growth from a graph. So instead of looking at tile patterns, we're going to be looking at graphs now. During this lesson, make sure you pretty much keep in mind these following focus questions. What makes my line steeper? What makes it less steep? How is growth related to the steepness? Where is the starting value of a line? So now let's look at problem 211 right there. The table below represents a tile pattern. So like as you guys learned in the previous lesson, same thing. So we have figure 0, and that's 2 tiles. Figure 1 has 7, 2 has 12, 3 has 17, and then 4 has 22. So the first thing they're asking us to do is make a graph that represents this tile pattern, and then answer the question, should the points be connected? So you guys should be able to graph it. So 1 right there. And then, sorry, it's not the right point. So 0, 2 would be right here. And then 1, 7. So 1, 7 would be in the middle of that right there. Not that one. 2, 12 would be over here. And then 3, 17 would be right in the middle of that one right there. And then finally 4, 22 would be right here. Now, should the points be connected is pretty much depending on the situation. Now, in this case, the situation is measuring tiles. So would you consider having like half a tile or not? So we can say in this, like, depending on the situation, right? So the situation is number of tiles. And if I can get, right, if I can get half a tile, then yes. All right. So if I can get half a tile, then yeah, it's fine. Like, it shouldn't be a bad idea to have it. And then it says part B, now draw a continuous line through the tile pattern points, extend the line to the edges of the graph and beyond. So they want us to connect this all the way. So we're going to keep connecting. Let's see the entire graph. So right there. And then also I want to go back in the negative side. So it's going to look something like this. All right. It's a lot easier if you guys use a ruler. Now it says the line you drew models the growth of the tile pattern. Models are often imperfect, but they are useful in describing complex situations and for making predictions. So what assumption does this linear model make about the tile pattern? So the first one should be pretty much, your first assumption can be like, we can have half a tile, right? Like, we can have half a tile. Or decimal tiles, we might want to say that, right? And that would be like broken pieces, if you guys can think about it that way. And then the other assumption we can make here is that we can go to the negative side of the figures, right? We can have negative tiles. So the other assumption is that we can have negative tiles. Oops. All right. And then question to 12, does the model in the previous problem appear to be a function? If so, write the equation in the function notation. If not, explain why it's not a function. So here we want to make sure, remember, we can use the vertical line test. So if we draw a vertical line through any part of the graph, if it touches more than one point, then it's not a function. So in this case, we can say, well, yeah, it is a function, right? Yes, it is a function. It passes a vertical line test. All right. Now let's look at problem 213. The three graphs below, we still want to write the equation for that function, right? So first, remember from the previous lesson, we learned that our figure 0 is our initial value or starting value. And then we can figure out the growth rate by determining how this is growing, right? So since we're going up by ones here, we can say that every time we go up by one, we go up, the number of tiles increases by, and in this case, it looks like it's 5. So each time we're adding 5 to the previous number of tiles, and that's how it pretty much increases. So that's our growth rate, right? Our growth rate is pretty much 5. So our initial value is 2, and then our growth rate is 5. So if you recall from the previous lesson, you guys can write it as, again, y. It's y equals, which was the growth, times x, which is the figure number, and then plus your initial value or your starting value, right? And then in this case, like we said, we have a growth rate of 5. So y equals 5 times x, and then our initial value is 2, so plus 2. And then the last question, or actually the next question, the three graphs below each model different tile patterns. So for each, describe how the tile pattern grows, and then in the starting value of the tiles in figure 0, x represents, again, the figure number, y represents the number of tiles in each figure. Write an equation that relates the figure number x to the number of tiles. And then finally, decide if the graph represents a function. If so, write the equation using function notation. If not, explain why the graph does not represent a function. So here, again, we want to see, so if you guys notice from the previous graph, our starting value is pretty much where it crosses the y-axis. So let's look at that first. So we can see that our figure 0, or starting value, has 3 tiles. So figure 0 has 3 tiles. And then our growth rate, so how much are we increasing by? So we go for figure 1, right? 1 to the right, and then we're increasing by 2 each time we go 1 to the right. So we can say that our growth rate equals 2. So therefore, here we want to write an equation that relates both the x and the y. So we're going to say y equals, and again, same thing, right? The growth rate times the number of tiles plus the initial value. So here, it's 2 times x, and then plus 3. So now in problem B, we have something similar, right? It's still a straight line. They're giving us different information, and then we can still determine. So we're still looking for the same thing. What is figure 0? And then if you notice again, it's positive 9 here, right? That's where it crosses the y-axis. So that's 9 tiles. And then the growth rate, looking at that, happens to be, so we go 1 to the right and then 12 up. So we're going, every time we move a figure number, we go up by 12. So that's equal to 12 each time, right? And then again, write the equation. So here, y equals the growth rate, which is 12 times x, and then your starting value, which is 9. And then finally, we look at problem C right there. So again, your figure 0, that's what you're looking for, figure 0 first, which happens to be your initial value is right there. So make sure you guys are counting correctly. 1, 2, 3. So 3 tiles. And then our growth rate. So how does this change from one figure to the next? So if you wouldn't move 1 to the right, you'll notice it goes 1 up each time. So our growth rate is 1. So again, write your equation. So y equals x plus 4. And now if you notice, I didn't write a 1 in front of the x. And the reason is because if it's a 1, you don't have to write it. So if you see an x, it's 1x pretty much, all right? Anything above that, you do have to write the number.